On this channel, we provide useful programming information with practical code examples. This time, we will focus on the IO module in Python. We will explain the IO module in Python with practical examples. Enabling subtitles will make the code descriptions easier to understand. Input-output processing forms the foundation for all kinds of data operations, such as files, networks, and standard I/O. Python's IO module provides a set of abstract classes that unify these input-output operations. The key concept to understanding this module is the idea of a stream. A stream is an abstract flow for reading and writing data sequentially and continuously. When reading file contents byte by byte or sending and receiving data over a network, all these can be handled as data streams. By abstracting this mechanism, files, memory, and networks, different sources of I/O, can be handled with common operations such as reading and writing. Python's IO module provides a unified interface for streams, allowing efficient handling of both text and binary data. The IO module has a three-layered hierarchy according to the nature of streams. Raw layer, raw I/O base. Raw I/O base handles the lowest level byte I/O, such as OS file descriptors and devices. Buffered layer, buffered I/O base. Buffered I/O base provides a cache buffer to improve I/O efficiency. Buffered reader and buffered writer are typical examples. Text layer, text I/O base. Text I/O base converts byte sequences to strings and handles encoding. Usually, when opening a file with the open function, text I/O wrapper from this layer is used. Thanks to this structure, the IO module clearly separates text and binary I/O while allowing flexible combinations. Raw I/O base handles OS file descriptors at the lowest layer, with buffered I/O base adding a cache on top, and the top layer, text I/O base, handling string conversions. This code is for checking the group of abstract classes inheriting from I/O base. You can see text I/O base, buffered I/O base, and raw I/O base, confirming the hierarchical structure. I/O base is the abstract base class for all I/O objects, defining common methods such as close, flush, and seekable. It is rarely used directly and usually accessed through derived classes. This example shows that the common methods of I/O base can also be used in upper classes. Seekable and readable are useful for checking the properties of a stream. Raw I/O base is the layer closest to the OS file descriptor and does not perform buffering. The typical implementation is file I/O, which reads and writes by byte. File I/O is a concrete implementation of raw I/O base, all reads and writes are performed as bytes. Efficiency can be improved by combining it with the upper, buffered I/O base layer. Buffered I/O base is an intermediate layer that performs buffering, making disk access more efficient. The main implementations are buffered reader, buffered writer, buffered random, and buffered RW pair. In this example, data written via buffered writer is temporarily stored in a memory buffer and is actually transferred to the lower layer upon calling flush. Buffered reader is a read-only buffered stream that supports efficient reading with peek and read. Peek only peeks at the data and does not move the pointer. By combining it with read, you can flexibly control buffering. Text I/O base is an abstraction layer for handling strings, internally performing decoding and encoding. A typical implementation class is Text I/O wrapper. In this example, Text I/O wrapper encodes the string to UTF-8 and writes it to the underlying binary stream. Decoding is performed automatically when reading. Text I/O wrapper serves as the fundamental class for Text I/O and forms the basis for almost all high-level file operations. String.io is a class that allows you to handle strings in memory as if they were files. It is useful for I/O testing and temporary data generation. String.io allows file-like operations without using the disk and is widely used in unit testing. Bytes.io is an in-memory file class for handling byte sequences, bytes. It is useful for situations such as binary processing or data compression where you do not want to use files. Bytes.io has the same interface as buffered I/O base and can be used as a substitute for many file APIs. The classes in IO are extensible, allowing you to create your own stream classes. Below is an example of a Text I/O base subclass that capitalizes all text on write. As long as you adhere to the contract of Text I/O base, you can define any custom behavior like this. It is also easy to extend streams for specific uses, such as files and networks. The IO module organizes input-output processing into a hierarchy of abstract and concrete classes. Raw I/O base is a class for oxygen monosulfide level byte I/O. Buffered I/O base is a class that provides an efficient cache layer. Text I/O base is a class that manages reading and writing of strings. String.io and Bytes.io are classes that provide in-memory streams. Understanding these classes allows you to accurately grasp the workings of Python's I/O system and apply them to file operations, network communication, and the design of test streams. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. See you in the next video. Please subscribe and give us a thumbs up.